So a question I get asked a lot in meetings is, does Slant3D, are we going to do metal sometime? Well, here's the answer to this. So Slant3D is a mass production 3D printer farm. We use the FDM process exclusively throughout our entire facility. And we'll do another video where we kind of explain that focus. But because of that, we were limited to filament type of materials and raw materials. But even though we're limited to filaments, we are able to print in metal. We are able to print with high fill plastics that have like an exceptional amount of like copper inside of them that we can do heat sinks with while they still maintain a polymer part where it's like 50-50 or 80-20 or something like that, to where you have the heat conductivity to create a heat sink, but you still have the polymer flow, which is very easy to work with. But true metal parts, where you print out a metal part with a binding agent and then you send it off to a sintering oven where it is baked together and you have a full, basically cast part that has been 3D printed at the end, is something that we do also. There's multiple materials out there. BASF and several other companies have produced high metal fill filaments where you can print out basically solid metal and then bake it and get a metal part out of it. And we have done these projects in the past. In fact, we started working on them about 3 or even 4 years ago, but it's not common. And the reason it's not common is because there's a very large design gap about where the benefit of metal 3D printing is compared to a sand cast part or just machining the part. The only reason to use metal 3D printed parts over traditional machining or molding is if you have a geometry that cannot be created any other way. And this has come up, again, for like heat sinks and that kind of stuff. Companies who are doing like lots of servers want exceptionally highly engineered heat sinks. So they pursue 3D printing because it can create geometries that move heat way better than traditional processes can. But the short answer is, yes, we do metal 3D printing. And the process for that is, okay, you order the part. We will say, okay, you can order the part there. You're generally going to be limited to about 100 to 1,000 parts. It's not really mass production yet, or we haven't had clients who have really pursued it or really optimized the design to allow mass production. But the way it goes is the part is ordered. We will go ahead and get in the material, whatever high metal fill it is, copper, iron, aluminum. We have a number of those. And we'll print the part, and we will print it traditionally. For the most part, you load up filament in the machine and you print out the part with a hot nozzle squirting out plastic. But from there, this is where the process slows down and is very inconsistent because those parts that are printed are not done. They're called green parts. Those green parts have to then be centered and bound together. So they have to go into an oven and be baked to get rid of the binder and to let the metal particles inside of the filament fuse together. There's a few things that go wrong at this stage. Number one, we don't have a sintering oven in-house. Again, it's something that's not very common, so we don't have production processes for the full life cycle of those parts. We print the parts, but then we send them off to a sintering company who will bake them. Problem is that now you have 3 people involved in this one project, and each time you have a handshake, there is a potential for something to go wrong. So we have to ship these green parts, which are relatively fragile and brittle. If we're moving thousands of them, many of them can be broken by UPS dropping them on the ground. So there's danger there, and there's a high rejection rate right there, which increases the cost of the part. And then at sintering, they have to go through and basically create a recipe basically by eyeballing it. Like an artist, there's not a hard scientific way of saying, okay, this part is this big, has this much mass, we should bake it for this long. There's that general rule of thumb. But if the geometry is weird, where you have a really thin component and then a really thick fat component, the binding process has to be very variable and kind of weird in order to protect the one part once it's already cooked and let the other part keep area of the same part keep on cooking. So that process is slow as they iterate through, which again is going to lose a bunch of parts. And as they iterate on the baking process, and then they send them back. And then there's no real way to qualify if the baking house actually baked them appropriately. Are they fully debound? Are they fully adhered together and fully solid metal? The other thing that can go into this is that as you bake them, they shrink. There's about a 20% shrink rate between the original design and that. We compensate for that. We scale up the part. We do some tweaks here and there and yonder so that when it's baked, it comes back into your true design. But again, big loss in tolerances. Big loss in tolerances. So very often you need more machining after you print the part to get it down to the true tolerances because you're dealing with a shrinkage of 20%. The standard deviation and error in that is enormous. No matter how good the printer is, material shrinking is not a very scientific way of getting a tolerance. So after all that, we print the part, we send it off, somebody bakes it, tries to bake it multiple times, stuff is broken in shipping, things are iterated through, so you lose a bunch there. And then you really don't know what is coming back. And since that process of baking is really quick, for us to do a sample, there's like a 2-week process of us do a sample, send it off to them, have them bake them, send it back to us and say, okay, that's good, we can make 1,000 more of those. And then we send it off to them. And then if they change the recipe or the guy is gone, then it doesn't print reliably again. So that is the process for metal 3D printing. We will do it if somebody requests it, but it is not something that we're focusing on right now and not something that we really list as a service. Because even though it increases marketing value and you get to say, we 3D print with metals, it's not valuable to the customer and it's not ready for the customer yet. So no, Slant3D really doesn't do metal 3D printing because it's so early in the technology and there is this big centering problem that exists to where it's not mature enough yet for us to use to produce final end products for our customers. And quite frankly, carbon fiber nylon is as good as aluminum, and we have many polymers that are as conductive as regular metals, so that covers heat sinks and most metal parts. So the other value of metal is kind of lost when we're already able to grab 25 to 50% of the parts made in metal with our standard polymer processes. So there's just no reason for us to focus in and try to build a process around metal 3D printing when it's not really ready yet. So hopefully that answers some questions about how Slant3D handles metal 3D printing. Comment down below about any other processes that you'd like to see or hear about, and we'll try to get them answered as soon as we can. Have a great day, everybody.